Welcome back to my video series. You have entered the realm of Calculus Conundrums by me, the Perfect Square, Kevin Pinegar. And on this video, this one's going to be relatively short. I'm just going to show you a couple of examples of how to find derivatives of inverse hyperbolic functions. Now, you may not even cover these in your course, and you definitely wouldn't cover these in a business calculus course, but these would only be covered in a Calculus 1 course. So if you want to find the derivative of the inverse hyperbolic sine of u, there's a formula for that. It's u prime over the square root of u squared plus 1. Now for the inverse hyperbolic cosine of u, the derivative of that would be u prime over the square root of u squared minus 1. For the inverse hyperbolic tangent function, it's u prime over 1 minus u squared. For the inverse hyperbolic cotangent of u, the derivative of that would be u prime over 1 minus u squared. And let me double check that, because these two being the same, I may have that wrong, but let me double check it. Okay, no, it was right. These are both u prime over 1 minus u squared. Now, there is something to say about the particular value of u, so you might want to go back and research the domain of u, because the domain of u for this formula and the domain of u for this formula is a little bit different, but we're not going to worry about that on my calculations. And then the inverse hyperbolic secant of u is minus u prime divided by u times the square root of 1 minus u squared. And then the inverse hyperbolic cosecant of u, the derivative would be minus u prime over absolute value of u times the square root of 1 plus u squared. Now I'm not going to do, I could do one of these for each of the 6 formulas, but I figure if I do a couple of them, you'll see how to apply the formula. So the first function I'm going to work with is this one here, the inverse hyperbolic sine of e to the 2x. Now go to the formula, which is right here, and notice in the numerator you put u prime. Now what would that mean? That would mean that we would, in the numerator, we would have the derivative of this argument here. And so the derivative of e to the 2x would be 2 times e to the 2x. Now the numerator would be the square root of u squared plus 1. So notice down here I have the square root, and then if I square u, that would be squaring e to the 2x. And if you square e to the 2x, you get e to the 4x. So the denominator would be square root of e to the 4x plus 1. And so that's pretty much it there. Now, this one we're going to do find the derivative of the inverse hyperbolic cosecant of natural log of x. And that would be this formula here. So in the numerator, I would have minus u prime. So now remember, u here is natural log of x. And so the derivative of that would be 1 over x, but I have to do minus that. So I'd have minus 1 over x. So you can see I've got that right there, minus 1 over x. And then in the denominator, I would have the absolute value of u. So I have the absolute value of natural log of x. And then times the square root of 1 plus u squared, so that would be the square root of 1 plus the natural log of x quantity squared. Now in this step over here, all I did was realize that I could simplify this by just moving x and putting x in the denominator, so I get minus 1 over x times the absolute value of natural log of x times this square root. And that's really all I'm going to show you for these. You can search the internet if you want to find some more formulas, but basically, some more examples, but basically we're just applying the particular formula to find the derivative. Okay, and that's pretty much it on my formulas for derivatives But I do have videos over implicit differentiation. And so if you don't know what implicit differentiation is, you can see my next video to learn what it's about.